All right, so continuing the problem from yesterday, a diet guide claims that you will get 120 calories from a serving of vanilla yogurt. What does this evidence indicate? Use your confidence interval to test an appropriate hypothesis and state your conclusion. So, let's start with our null hypothesis. What would that be? U is equal to what? 120 calories. So what would our alternate be?
U is less than U is
Just not equal to 20?
Yeah, not equal.
So it's 2.
It means 120.
Yep, not equal to 120.
Because it's not specifically asking.
Right.
If they want to see if it's greater or not.
Yeah, they're just saying that you do get 120. So our alternate would be that we don't. But what do we know about this?
That is
It's
definitely not
on
in
the
our confidence
table, but it's not in our confidence interval.
Right. It's not in our interval. Our interval does not contain 120 calories. So it's not correct in what they said. So do we reject or fail to reject?
We reject.
Yep. Based on the interval, we reject the null hypothesis. Because the estimate is too low. So a company claims its program will allow your computer to download a movie quickly. We'll test the free evaluation copy by downloading a movie several times, hoping to estimate the mean download time with a margin of error of only 8 minutes. We think the standard deviation of the download times is about 10 minutes. How many trial downloads must we run if we want a 95% confidence in our estimate with a margin of error of only 8 minutes? So we're going to need our formula. So margin of error is equal to T star sub df times S divided by the square root of n. And I'm trying to basically solve for n, right? I have everything else given to me. But can I do T star without knowing n? No. What did we say we would have to do when we don't have that? Remember what we said we had to compare it to? Huh?
Give up and go home.
Give up and go home.
I was gonna say solve.
My brain is kind of
Compare
fried.
Because right now we technically have two unknown things. Okay, I have standard deviation and I know what I want the margin of error to be. I know that I'm trying to actually solve for n, but I don't have t. So there was something that we talked about that we said, if you don't have t, because you don't know n, use z. Okay? And then we may have to go back and rerun it to actually get the correct value, depending on what we have. So, what would z be for a 95% confidence interval? 1.96. So I'm going to have 8 is equal to 1.96. And again, you might just want to note that that's z star instead. Times 10 over the square root of n. So I am dividing by 1.96 and dividing by 10, so 8 over 1.96 and 10 is equal to 1 over the square root of n. I can flip both fractions since I have two fractions and square both sides. So that's going to end up giving me that n is equal to 1.96 times 10 over 8 squared.
Guess I should turn my calculator on.
Usually helpful. So that's equal to 6. So what does that mean that our degrees of freedom actually is for this then? 5. Now, we are going to revise this now that we know what our n is with our t star for degrees of freedom 5 at a 95% confidence interval. So if we do that and we go to our lovely table for 0.05 for the two-tail and 5 for the degrees of freedom, we would get t star is 2.571. So t star for 5 is 2.571. And so then I'm going to rerun this solving for n with this updated number now. And so 8 equals 2.571 times 10 over the square root of n. And so basically I'm just swapping out the 1.96 from over here. So just to not have to write so much, I'm going to have 2.571 times 10 over 8 squared. And I'm going to get my new n value. Now, can I do a partial download?
I mean, yeah.
Okay, well,
Well, like, no.
no, because I need to know the download time, which would be complete. And so I'm going to actually round this up. So I would say that we round to n is equal to 11 trial downloads. So notice that number is, realistically pretty different than our original one, right? But I'm just using that to get me close enough to something that I can deal with, because if I don't know my sample size, I can't use t star. So z allows us to, it's an acceptable way to find that. All right, last question. All right, in 2004, a team of researchers published a study of contaminants in farmed salmon. Fish from many sources were analyzed for 14 organic contaminants. The study expressed concerns about the level of contaminants found. One of those was the insecticide Meyer, which has been shown to be a
Carcinogenic.
Okay, cool. Thanks. I was like, the IC on the end was really throwing me for a loop there. And is suspected to be toxic to the liver, kidneys, and endocrine system. One farm in particular produced salmon with very high levels of, okay, I think it's supposed to be Murex, but whatever. After those outliers were removed, summaries for the Murex concentrations in parts per million, that's what ppm is, in the rest of the farm salmon are, and so then they give us N, the Y is our average, like our Y bar, and then S is our standard deviation there that's given to us. So what does a 95% confidence interval say about Murex? So what are my degrees of freedom? 149. So I'm going to use the calculator function T interval.
Where's that at again?
Staff test.
Yeah. Yes.
Go down to 8.
And it'll be your X bar, or in our case Y, 0.0913, then standard deviation 0.0495, then N, it asks for N, right, not degrees of freedom.
Yeah, that's right.
Okay. And then 0.95 because we want a 95% confidence.
How far out do you want us to go?
Just go to 3.
0.083 to 0.099.
So, this would tell me that I am 95% confident that salmon I was gonna say from this farm. I don't remember if it's talking about just the one farm in general or all of them.
It says many sources. So
I
don't
think
know.
it's just the.
I'll
standard
just say
of that.
I'll just say from the farms.
Okay.
I'm like
From the farm salmon.
contain 0.083 to 0.099 ppms of Murex on average. Researchers purchased whole farm salmon from 51 farms in 8 regions in 6 countries. The histogram shows that concentrations of the insecticide Murex in 150 farms shows the concentration of insecticide Murex in 150 farm salmon. Are the assumptions and conditions for inference satisfied? So are we independent?
Yes.
Yes.
Are we random, or at least a representative sample?
Yes.
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 They went to 6 countries.
10% condition, is this less than 10% of all farmed salmon?
I'm hoping so.
And nearly normal, greater than 40, so what?
Yeah.
So yes.
So we assume so. Now, if they don't give us enough information to be able to do,
Or the 51 farm. Wait. Is it the 150 farm salmon?
yes,
Okay.
the salmon, yeah. I was looking at the quantity of farms, but both
I
things
know,
are
I was like,
over.
wait, I
Yeah,
know.
no, it's what you're specifically looking at.
Okay.
Yeah. So that would be because it's over 40, unless it says otherwise, or if we actually were given like a table of information like we were in that one the other day, or
Yeah.
the one the other day yesterday, then obviously if we look at the histogram of that and it's, way off or something. But as long as that number's big enough, then I think they tend to give us ones that are over the, over that, so you don't really have to check. But So we would say that the conditions are met. Obviously, again, if this was a short answer question, you'd want to write them out.
Yeah.
And I would explain, like, that you didn't, like, you didn't actually look at the histogram, but because that number is greater than 40, you can assume that it's nearly normal, as it doesn't give us any reason to think that it's not. So as a safety recommendation to recreational fishers, the Environmental Protection Agency, the EPA, recommended screening value for Murex is 0.08 ppm. Are farm salmon contaminated beyond the level permitted by the EPA? Perform a hypothesis test. So what would my null hypothesis be? And then what would my alternate be?
It's
Right.
greater.
It is greater than 0.08 ppm. And what does that imply if it's greater than?
It's illegal.
Yep, illegal, unsafe. So just note that there just for, reference. Now, I can do this a couple different ways mathematically. I can use the formula for T sub 149 and get a value, so that would be 0.0913 minus 0.08 divided by standard deviation divided by the square root of the sample, so 0.0495 over the square root of 150. And we can get an approximate value here. The other thing we can do is we can run a t-test. So that's under stat and then test and then t-test. And we are going to input stats for this one because of what we're given. So we're looking at a t-test. So it'll be for stats. Then 0.08 x bar is the 0.0913. S sub x is 0.0495. N is 150. Yeah. And we're looking at greater than. And I'm looking for the p-value that comes out of this. And what is that?
How far do you want to go out?
Let's just go to 3.
0.003.
003. And what is the t-value that they give us? Because that t-value would really be solving this equation here.
Okay. T is 2.796.
Okay. Now, if you actually work this might be a little over or a little under because obviously this is done by hand. They're getting an actual value.
Yeah.
But anyways, and we could find that just by looking at our chart as well, our t-chart that we had. So this p-value is 0.003, and what is our alpha for this?
It is
I'm sorry.
0.05.
0.05, so that's less than 0.05, which is alpha. So what does that mean? I reject the null hypothesis. And what does that mean? So,
So it's illegal.
do we have enough evidence?
We have.
There is or is not?
Yes, there is enough.
So there is enough evidence to suggest the farmer's salmon is unsafe to eat.